8x squared plus 22x plus 15. Now, whenever you're confronted with a polynomial to factor, the first thing you want to look for, is there a common factor? There's not. Then, is it a perfect square trinomial? No, the first term isn't a perfect square, the last term isn't. Is it an a equals 1 trinomial? Because then we have an easy way of dealing with those, and it's not. So then you realize it's not an a equals 1, it's not a perfect square trinomial, so we have to get down and do decomposition, or PSF. Okay, and this is how we do it. All right, so we're looking for two numbers that add up to give you the middle term. So the middle term first, okay, and that's going to be your sum. We're looking for two numbers that add up to give you 22, and two numbers that multiply to give you the product of the first and last terms. So 8x squared times 15x is 120x squared. So we're looking for two numbers that add up to give you 22 and multiply to give you 120. Okay, so 12 times 10 is the first thing that comes to mind. Okay, 12 times 10 multiplies to give you 20 and adds up to give you 22. All right, so what we're looking for are 10x and 12. All right, 10 and 12 add to give you 22 and they multiply to give you 120. So we're going to replace the 22 with the 10x and the 12. So we have 8x squared plus 12x plus 10x plus 15. Now I arranged them just so it would factor nicely. I could have left the 10x here and the 12 and it would still work out. Okay, the order doesn't really matter, but you wanna arrange them so you can factor. Like I noticed that the 8 and 12 had a 4 common. All right, but the 8 and 10 would have had a 2 common. It still would have worked out, and the 12 and 15 would have had a 3 common. In any case, you just want to arrange them so they factor nicely in your mind, and away we go. So what's common to 8x squared and 12x? Well, 4 and x, right? So we're going to factor out the 4x, and we're left with 2x plus 3. If you factor out what's common here between the 10x and the 15, 5. So we factor out the 5, and we're left with 2x plus 3. What you have left in the brackets have to be identical. If they're not identical, then you've made a mistake. All right? So the brackets are identical. Now we factor those brackets out. So you remove the 2x, you remove the 3, you remove the 2x plus 3, the bracket, and you're left with 4x plus 5. Okay, so we fully factored it. Now this is a nice trick and all. The question is, why does it work? Okay, so let's say we take ax plus b times cx plus d. So your first term is a, and your second term is b, and your third term is c and d. So these are just numbers. Okay, and if I multiply them out, the ax multiplies the cx, you get ac x squared. The a multiplies the d, you get adx. The b multiplies the c, you get bcx. The b multiplies the d, you get bd. So we're looking, and then you would add these together, right? So we're looking for two numbers that add up to give you, AD plus BC. Okay, so we're looking, this is going to be the sum. Then, now remember, there's infinitely many numbers that are going to add up to give you any other number, right? So if you have two numbers that add up to give you 22, for example, you have like 1 and 21, or negative 1 and 23, okay? And you can just keep going, further and further away, like 2 and 20, or negative 2 and 24, right? So there's infinitely many possibilities. So just looking at the sum isn't going to do it. So what we want to do is have two numbers that multiply. Notice if we took the AC and we multiplied it, that first term, multiplied by the last term, it gives us the same A, D, B, and C. So watch what happens. So AC times BD, now if we just rearrange it a little bit, we get AD times BC, AD, BC. Okay, so two numbers who add up to give you the sum and who multiply to give you the product of the first and last. And that's why we are multiplying the first and last, so we can get the same AD, BC, AD, BC. Okay, and what numbers are they? Well, obviously AD and BC. Okay, so that's why it works, and this is what we do. So that's it. I'll give you a couple more examples as well. Have a good day.